So this is the back side of the review for unit number 1, and we're going to look at problem 17. Chase Field opens its gates on game day at 2 p.m. The attendance that day can be modeled by the following equation. If you happen to have a highlighter, I'd like you to highlight. If you don't, please just put a big box around it. This is going to represent the time that we go back to. So whenever we are checking time, we always go back to 2 o'clock. Now, I'm going to grab a separate piece of paper, and I'm going to do a quick review. I'm going to do a quick review on what this looks like. You do not have to write this down. Again, I am filming this for anybody who needs to go back and watch. So we have X's and Y's on a calculator. Now, for this problem, we think of this as T, and T is in terms of hours, and A of T is the population in terms of people. Okay, and here it's a specific time that we are provided. So 2 p.m. 2 p.m. is when the doors open. We're going to call that T sub 0. And at this time, all I'm going to do is I'm going to practice reviewing what do T's mean in terms of a specific time I'm given. If I give you 3 o'clock, that would be 1. If I give you 4:15, how do we translate 4:15 into T values? Well, the difference in time from 2 o'clock to 4 o'clock is 2 hours, and there's additional how many minutes? 15 minutes, and how many minutes are in an hour? 60. If I said to you 6:30, from 2 to 6 is a difference of 4 hours, there's an additional 30 minutes, and there's 60 minutes in an hour. Now let's use that information to come back here and to answer these questions. Okay, let's start by only doing part A. So we're going to grab our calculator. There has been a lot of confusion in how do we plug this in. I always start by clearing the calculator screen, so second plus 712, and now we're going to go to y equals. Whenever you're provided with a fraction, always put parentheses around the top and parentheses around the bottom. Please type this in as I do the same. It's not uncommon that I make a small mistake, or I see students make small mistakes, and so I'm just going to advise you to go back and make sure you plugged it in correctly. One of the things I did see students struggle with today is they saw a T here, and then they're thinking, like, where do I find a T on a calculator? When we take this formula and we plug it back in, A of T is the same as Y, and X will replace the T. When you're done, I want you to go to Windows. When you're done, please go to Windows. And we're going to come back to this in just a second. Now I want to go back and I want to read through each of these questions before I actually graph it in an appropriate window and draw a picture. So before I do that, I am going to start by putting a box with a highlighter around what I'm trying to find, and I'm going to underline the given information. So when it says to me how many fans, are they asking for, if I come back over here, when it says how many fans, are they asking for time or are they asking for population? The population or attendance, that's your Y value. I want to know what is a Y value when I'm given a specific time. Now, another thing you need to recognize is what is 5 p.m. And it all goes back to knowing that the initial time is 2 o'clock. Turn to your partner, and in the next 10 seconds, I want you to tell your partner what would be the T value at 5 o'clock. Go ahead. It is 3. So I'm going to write all of this down. I'd prefer you to do the same. How did I come up with T? It's the time after 2 o'clock. We'll do this on a calculator later. I'm going to go on to part C. How many fans? Again, I want to know what is the attendance. What is the attendance or the population in the venue? And I'm given a time of 7:35. So from 2 to 7 is how many hours? 2 to 7 is a difference of 5 hours, but this time we have additional minutes. There are 35 additional minutes. And sometimes the confusion is, what do I put on the bottom? How many minutes are there in an hour? 16. Okay. In part D, it says what time. And as simple of a question as that is, right now if I said to you what time it is, you would say 10:44 a.m. That's the type of answer you're going to give me eventually. So down here, That's hours and minutes, just like right now it is 10:44 a.m. But before I can get to that, I want you to put down these lines, hours and minutes past 2 p.m. That will help me to achieve this answer. Lastly, what is the attendance? Well, what is the attendance? It's just an alternative way to say how many fans. So I want to know how many fans or what is the attendance. That's a Y value. And I'm given a T value. Well, I have 10 o'clock from 2 to 10 is 8. Now, if you're wondering, why do I do this in advance? You don't have to. That's how my brain organizes information. And the reason why I do that in advance is I want to look over the T's. I know T's are like X's. So I need to go to at least 3. Well, I need to go a little past 5. I need to go to at least 8. A minimum of 8. I think I'll even go past 8. So when I come up here, I know if I go up, I turn this on, I know that Windows, we can't have 0 time. Sorry, we can't have negative time, so I changed negative 10 to a 0. And I need to go out somewhere past 8. I think I'll go to 10. Now, when I graph this, I'm going to hit Zoom Fit. So you can either scroll down to Zoom Fit or hit Zoom 0. I'm going to come back to Windows if you were not able to get that. I change this from 0 to 10 and hit Zoom Fit. Thumbs up in the high in the air or thumbs down. I got this. I don't have this. Okay, next. The easiest points you can get is to draw this picture. So you're going to go to Window, and we're literally going to identify the minimum and maximum for the Y and the X. So 0 to 10 and 815 to 42, 386. And then I'm going to draw the picture. Okay, it's time to answer these questions. Part B and Part C, we're going to do the same type of calculator operations. Davey, can you show off one light for me, please? The same type of calculator operations. I'm given a T, which is like an X, and I want to find the corresponding Y. Remember, Y talks about the population or attendance at the event. Second, trace value, typing in 3 for the X, and now I'm going to round this to the nearest whole number. 18,580 when I round it to the nearest whole number. What does this mean? At 5 p.m. at Chase Field, when the gates open at 2 p.m., at 5 p.m., we can assume there'd be 18,580 people. Let's do Part C. Second, trace value. Now I'm going to go to 5 hours past 2 p.m. plus an additional 35 minutes. Make sure that your fraction does go in parentheses. Okay, 40,000, and I'm going to round to the nearest whole number, 235. The way we do Part D is different than B and C. Now, instead of being given an X value or T value, those are interchangeable, I'm given an actual Y value. I'm given the amount of people within the stadium. So please go up to Y equals and go down to the first open space, and let's type in 24,000. And then hit graph. We do not want to round here. Do not round. We want that exact amount so I can be as precise as possible when I actually evaluate the time when there's 24,000 people exactly in the stadium. So let's go second, trace, intersect. And because there is only 2 lines, it's pretty simple. I could get to hit enter 3 times. Can you please raise your hand if you have the exact same answer that I have? Hands up high. Okay, I want you to write this down exactly somewhere off to the side. So off to the side, I'm writing down this amount. And we're going to talk about what does that really mean in a second. This means 3 hours past 2 p.m. So 3 hours. And now there's not 41 minutes. This is a portion of an hour. So I'm going to go back and press second quit. I'm going to plug in the decimal amount. And then I ask myself, how many minutes are there in an hour. How many minutes in an hour? There's 60. And I'm going to round my answer to the nearest minute. So this could round to 25 minutes. So the most common mistake I see in probably 50% of the students today is they do all of this work. I know they have a great understanding, but then they answer it wrong. 3 hours and 25 minutes past 2 p.m. What time would it be? Whisper to your partner, don't tell me. What is 3 hours and 25 minutes past 2 p.m.? 5:25. So 3 plus 2 is 5, and here's the additional 25 minutes. Our very last one is E. E is just like option B and option C. So I'm going to come up to the top, go back to my graph. I want to know what is the attendance or the population in the venue at 10 p.m. A common mistake I see is people go second trace value and they type in 10. We're not looking for 10, we're looking for the T value. So how many hours past 10 p.m.? It is 8 hours. Okay, let's round this to the nearest whole number, which is 42,280. A new fax machine was purchased on January 1st, 1998. I would like you to highlight that and put a star or an asterisk next to it. That is the initial amount. Just like we came back to 2 o'clock, we are coming back to January 1st, 1998. And I'm going to draw a little arrow to 800 because when it was purchased, it says the value or the price was $800. 4 years later, the value was only $600. Whenever you see use algebra to create a model, I'm asking you to come up with the equation y equals mx plus b. Now, in order to do that, you have to have at least 2 points. So let's create those points. I know this is not enough room for your test. I'll make sure there's more space. Please do me a favor, write really small. We're going to come up with 2 ordered pairs. So let's talk about t values here. Let's talk about t values, okay? This is going to be time. And this is going to be the value of the fax machine, okay? X and Y, independent and dependent. When it was purchased, initially was purchased, that's time 0. That's t equals 0. What was the value? 800. That means I have 1 ordered pair of 0 and 800. What's the next fact that I'm provided up above? Okay, when t is 4, what is the value? 600. Now, it says you have to show your work using algebra. So I'm going to have you use the equation y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, I'm going to show my work, and I'm going to use a calculator to ensure I did it correctly. So this is x1 and y1 because it's my first point, and x2 and y2 because it's my second point. And then I'm going to plug them in. Okay, y2 minus y1. y2 is 600. y1 is 800. x2 is 4. x1 is 0. 600 minus 800 is negative 200. 4 minus 0 is 4. What if you don't reduce that? It's not going to be wrong. It's not going to be wrong. You'll still get the same answer. Now grab your calculator. What could be an alternative? Type in right now, negative 200 divided by 4. I could also express this value as negative 50. So whether you say m equals negative 200 over 4, and maybe your partner says negative 50, they're the same value, just different forms. What do we do next? Well, there's not a lot of room here, and obviously maybe I don't write small enough, but y equals, I know my m, x plus b. Later on, we're going to talk about how can we identify the b without sometimes having to plug in values for word problems. But right now, let's use our points. Which point do you prefer to use? There's no wrong answer. So I could choose this point and you could choose this point. We're going to get the same b value. Now, I personally am choosing the first ordered pair. Does anybody know why I'm choosing that? Has a 0. And anytime something has a 0 or a 1, I'm like, yes, that looks like an easier point to use. This will replace X and this will replace Y. Negative 50 times 0 is 0, and there's my answer. B equals 800. Once you have an M and you have a B, you can write your final answer down. So I'm going to grab a different colored pen for myself so it stands out for you guys. Y equals negative 50x plus 800. And again, we'll talk later on about how we could have identified 800 as the initial, just based on the time we have here. Okay, based on this is our initial value. So that would have been another way to identify 800. Okay, you ready? Now, before we plug this into the calculator, let's start by doing second plus 712. Second plus 712. Go to y equals, and let's type it in, negative 50x plus 800. And then let's take the calculator and set it off to the side. Take the calculator, set it off to the side. Use the model to calculate, and I'm going to grab this, how much. So when they say how much, they're talking about a value. They're talking about a y value. And the y value is going to be in terms of money. So when I do give an answer, I can give it something like this. I'm going to make this up. $250.30, right? I can do and round to the nearest hundredth with money. Now, what is this t value? The great thing is we went from January 1st to January 1st, so there's no additional days. And the difference in time, whisper to your partner, what is the t value, 1998 to 2005? You can count on your fingers, use a calculator, do mental math. Whisper to your partner, don't tell me, you have 10 seconds, go. T value is 7. Again, you could simply subtract 2005, subtract 1998. Let's go on to part C. Again, please go ahead with me and highlight, box in, whether you're using a different type of writing utensil. We want to identify what we're trying to find. We want to know how much. My answer is going to be a number that represents money or value. Now, this is where it gets a little more difficult. The years have only gone up 3. I want to show that again. 1998 to 2001, that's only a difference of 3 years. But now we have these additional days, 60 extra days, and this will be provided for you. So 60 days, turn to your partner. What number goes on the bottom? 365. All right, let's go on to the next one, please. How many years? So my answer is not going to be monetary in value. It's going to be how many years will it take to be worthless? If something is worthless, it has no value. So in this problem, X is time in years and Y is the value. So when Y equals 0, what is our X? And our last one is going to be on what exact date? On what exact date? So I'm going to come over here and write we have some month, some day, and some year. Now before I can do that, I'm going to get a value in terms of years and days, and then I'll convert it into months, days, and years. Okay, if you're ready, here we go. Let's go back up here. I'm looking at my t values, and I'm trying to figure out which t value goes out the furthest. That helps me to identify what do I put in for X. Please go to Window. X represents years. I need to go to at least 7. I may even go a little further. We can't have negative years. Let's go 0 to 10. And then do zoom fit. 0 to 10 with a zoom fit. Please put a red cup on top if you and your partner have a graph that looks like mine. This makes sense. The value of the fax machine decreases over time. Now, one thing I do want to note is that, do you see how it hits right here? Let's go back and go out a little bit further. Let's go out to 12 and see. I want to be able to have a better idea of exactly what this is. Okay, we're ready to start. T is the same as X. So second, trace value and go to 7. Okay, so at exactly 7 years after it was purchased, the value of the fax machine would be $450. Please go ahead and do part C. You have 30 seconds.
Do we round up to the nearest power?
You can round to the nearest cents. Whenever you plug in a fraction, please put it in parentheses. 641.78. Can you give me right now a thumbs up? I'm feeling pretty good about this problem. Thumbs to the side, I'm kind of in the middle. Thumbs down, I'm sorry, Miss Bradley, I'm paying attention, but this is not making any sense to me. Thumbs up, to the side, or down. Go ahead, please. Where are we right now? Okay, thank you. How many years until the value is worthless? Go to y equals. And before I do, I'm going to go y equals and go down to 0. And then I want you to go to Windows. Now, is 0 in between the range of 300 to 800? Is 0 between 300 to 800? No. Now, I could, please don't do the same. I could make this 0, but I could barely see it then. I could barely see it. I want to go something that's lower than 0. So it could be any number lower, like maybe -50, -100, something that allows you the opportunity to see this. Now, I want to graph it, and I want to know where do they cross. I can see they're eventually going to cross, and if this was an iPhone, I would just say, okay, swipe this way so we can see out here. But on this particular device, I need to move the X's out further. Now, how far do you know to move them? You don't know. You take a guess. Try 15, try 20 until you can see where they intersect. Because I've done this now 3 times today, I know I need to go out past 15, I believe. I'm going to go out to 20. Please use the intersection button or use the 0 key, the 0 feature, to find out what is this exact precise point. And the answer is how many years? 16. All right, here we go. So just like we asked when was it worthless, now we're saying when was it worth $599? Let's go back up here, go to 0 and change it to $599. We're not always going to get a nice whole number like 16. Second, trace, intersect. Second, trace, intersect, enter, enter, enter. I want to write this down off to the side. I'd like you to do the same. If you and your partner have an answer of 4.02, can you put a green cup on top, please? 4.02. So what does this mean? What does 4.02 mean? Let's come down here. This means it would be 4 years past this initial purchase date until the value is $599. But there's some more. Does this mean 2 days? It does not. Come back up here. Let's clear it out and type in 0.02. How many days are there in a year? We're going to round this to the nearest whole number. Oh, I'm sorry. 0.02 times 365. Rounded to the nearest whole number is 5. Rounded to the nearest whole number is 5. You don't have the same? Did you get 0.02? You did not. You're looking at me funny. I'll come back up here. Okay. I typed in 599. I graphed it, and I want to know where do they intersect. Second, trace, intersect. This is where it intersects. This is the time, 4.02. Now, I need to translate that into years and days. That's 4 full years, and I use the partial, the leftover past 4 years, and I ask myself, how many days are there in a year? 365. This rounds to 7 days. What do I do with that information? I need to add 4 years onto the initial date. What is 4 years past 1998? 2002. If you add 7 days onto January 1st, 7 days onto January 1st would end up on January 8th. If I asked you for the value of the fax machine on March 21st, 2005, I'm going to go second trace value. Now notice the difference in years. What is the difference in years? 7 plus there's 80 additional days. This will be provided for you. And 365 days in a year. We're going to round this here to $439.04. So if we calculate the value of the fax machine on May 1st, 2007, that's 120 days past January 1st. The first thing I do is I calculate what is the difference in years. That's a difference of 9. You could take 207, subtract 1998 to get 9. Oh, so sorry. So I come back up here. I'm going to graph this. Second trace value, I type in 9. And then how many additional days? 120 divided by 365. The value would be $333.56. So I'm going to go through and do another problem like Part E. I'm going to change $5.99 to $547.50. So on the graphing calculator, I'll come down. This is the value, and I want to know the exact number of time. At what date can we assume? Again, it was purchased on January 1st, 1998. When will it be worth this? So I put in that value, and I want to find the intersection, second trace, and I want to go down to intersection, pressing enter 3 times. I come up with 5.05. By a raise of hands, who does have 5.05? Okay, good. Now what does this mean? This means 5 years, and this does not mean 5 days. So with 0.05, what am I multiplying by? 365. Why? How many days are there in a year? 365. Let's round to the nearest whole number. Now, we start on January 1st, 1998. If you add 5 years to 1998, and you can use a calculator, if you had 5 years to 1998, you would end up with 2003. If you add 18 days on to January 1st, it would be January 19th. Our last problem in this video is going to talk about the pathway of a ball. And so I would like you to come over here. Your height is going to be y. That's a height above the ground. And this is going to be horizontal distance. How far did the ball go horizontally? That's going to be your x value. We're going to use a regression model, specifically a quadratic regression model. So you start by going second plus 712 and going to stat. Second plus 712 and going to stat and pressing edit. Now, in L1, you're going to go down to 10, 20, and 30, plug those in, and then the... All right, coming back here, so I'm plugging in the information. This is my x, this is my y. I'm going to stat, and I'm going to calculate. Now, what do I know to go down to? I'm going to go all the way down here to quadratic regression. And when you get down to quadratic regression, you're going to press enter until you come up with the A, the B, and the C value. How do I know how to take that and to put that back into the calculator? Like, there's a way we copy and paste this. Everybody go to y equals. Does anybody remember the first step? VARS. Now go to statistics, EQ, and enter. Okay, let's go up to window. Remember, X represents the distance that the ball is going to be throwing. So this is like in the first quadrant. There's no negative distance. This quarterback, Andrew, he's not throwing the ball backwards. He's throwing the ball forward. So it's only positive distance. It starts at 0, and we know it's going to go to at least 30. It may be even more. I'm going to try going from 0 to 40, and I may have to adjust the problem as it goes on. When you're done, please hit Zoom Fit. I want to see the entire way. You know, Manny, he didn't time this right, and he tried to jump up to catch the ball, and the ball went right past him and hit the ground. So I need to see, where does the ball actually hit the ground? If this was an Apple phone, I would be able just to do this. I need to go out to the X's. So go to Window, and let's try 60. Does 60 go far enough? Okay. All right, we have the general idea right now. Now we need to actually, part A is they want us to actually draw this picture. So let's go to Windows and write down what we have. We're going to go from 0 to 60. And we're going to go from 6 all the way up to 24 approximately. When you're done, you're going to hit graph. So we've done part A, we've graphed it in the appropriate window. What is the maximum height? So I want to know what is the height. Remember, height is going to be the Y value. So second trace maximum, we're going to go somewhere to the left. I need to hustle up here to make sure we get done before the period ends. Somewhere to the right. And now there was big confusion about this. How do I know if it's the X or the Y? Again, Y is going to be the height. Your X is the distance the ball travels horizontally. So 24.75, 24.75 feet. That's how high the ball goes off the ground. It's a pretty high thrown ball. All right. How many yards did the ball travel before Manny Campos jumped up and caught the ball 8 feet in the air? We probably should have changed that 8 feet. I don't think his hops are that great, but we'll go with it. We're going to go with it. We're going to go with it, okay? All right. So we want to know 8 feet in the air. This is my line. He catches it 8 feet in the air. So let's go over here, go to Y equals, and change to 8. Now, I want you to answer this honestly. And truthfully, if you maybe don't understand football, does Manny catch it right here?
No.
Or does he catch it when the ball is descending further down the field? Find this intersection point. Go. Okay, now remember exactly, I heard somebody say that. This is in yards. The distance on a football field is measured in yards. So if we round this to the nearest, let's go to the 10th, 48.6 yards. That would be a really long pass, right, Manny? Really long pass, especially for a high schooler. Okay, am I right? Yeah. So how many feet in inches would the ball have traveled if Manny went up to catch the ball, but did not? He didn't accelerate up far enough. The ball went past him, and it hits the ground. I want to know, where does this hit? Okay, go ahead. Come up with that decimal, and then stop. And then we need to translate that into feet and inches. Remember that horizontally it's being measured in yards. We're going to translate it to feet and inches shortly. How do I figure out that point? Let's find it. Well, I'm going to use second trace 0. Second trace 0. And so I know somewhere over here, I don't know, let's try 40. And I need to go somewhere over here, let's try 55. Okay, and that's in between. I press enter. This is what I come up with. I'm going to give you right now an additional 30 seconds, knowing that in the last few hours, very few students were able to get this answer. Do me a favor, please. Put your cups side by side when both of you have this answer. Put your cups side by side when both of you have this answer. Okay, here we go. We have this answer, but that's in yards because horizontally it's measured in yards. We need to translate this to feet. Who can tell me how many feet are there in a yard? 3. So come back up. Let's type this in exactly. Take it times 3. This is the exact number of feet. Now there's additional part. We have at least 161 feet. Now this remainder, 0.168439. 0.168439. What do I multiply that by? Don't tell me, tell your partner. How do you know what number to multiply that by based on what we see? Whisper to your partner, go. You ask yourself, how many inches are there in 1 foot? The answer is, and let's round to the nearest inch, of 2.